This is SpaceTime, Series 29, Episode 4, for broadcast on the 9th of January 2026. Coming up on SpaceTime, do all galaxies have supermassive black holes at their centres? Still no evidence of alien intelligence on the Comet 3I Atlas, and a new study testing how rocket plumes interact with the lunar surface. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that most smaller galaxies may not have a supermassive black hole in their centre. For decades now, astronomers have believed that most, if not all, galaxies feature a central supermassive black hole around which the entire galaxy revolves. But this new study using NASA's Chandra X-ray Observatory has concluded that most smaller galaxies don't seem to have a core supermassive black hole. The findings, reported in the Astrophysical Journal, are based on data from over 1,600 galaxies collected over 2 decades using Chandra. The authors looked at galaxies ranging in size from more than 10 times the mass of the Milky Way down to dwarf galaxies which have stellar masses less than just a few percent that of our home galaxy. They found that only about 30% of dwarf galaxies are likely to contain a supermassive black hole. The study's lead author, Fran Zhao from the University of Michigan in Ann Arbor, says it's important to get an accurate black hole head count for these smaller galaxies, and it's more than just bookkeeping. He says the study gives clues about how supermassive black holes are formed. As material falls into a black hole, it's heated by friction and powerful gravitational forces producing X-rays. Many of the massive galaxies in the study contain bright X-ray sources at their centres, a clear signature of a supermassive black hole in their core. Zhao and colleagues found that more than 90% of massive galaxies, including those with masses the size of the Milky Way, contain supermassive black holes. However, the authors also found that smaller galaxies in the study usually did not have these unambiguous black hole signatures. In fact, galaxies with less than 3 billion times the mass of the Sun, which is about the same mass as the Large Magellanic Cloud, a neighbouring satellite dwarf galaxy to the Milky Way, usually don't contain bright X-ray sources at their centres. Now, there are 2 possible explanations for this lack of X-ray source. The first is that the fraction of galaxies containing supermassive black holes is much lower in these smaller galaxies, and the second is that the amount of X-ray energy being produced by matter falling onto these small galaxy supermassive black holes is so faint Chandra simply couldn't detect it. Now, the authors think that based on their analysis of the Chandra data, the conclusion is that there really are fewer black holes in these smaller galaxies compared to their larger counterparts. To reach their conclusion, Zhao and colleagues considered both possibilities for a lack of X-ray sources in small galaxies in their large Chandra sample. The amount of material falling onto the accretion disk of a black hole determines how bright or faint they are in X-rays. Because smaller black holes are expected to pull in less gas anyway than larger ones, they should have fainter X-rays and are therefore often not detectable. However, the authors found that an additional deficit of X-ray sources was seen in less massive galaxies, beyond the expected decline of decreases in the amount of gas falling inwards. This additional deficit can be accounted for if many of the low-mass galaxies simply don't have any black holes at their centres. The findings have important implications for understanding how supermassive black holes are formed. Right now, there are 2 primary hypotheses to try and explain how supermassive black holes are created. The first involves giant clouds of gas collapsing directly to form a supermassive black hole. These contain thousands to billions of times the mass of the Sun. The other idea is that supermassive black holes instead are created by the merger of many smaller stellar mass black holes, which themselves are created through the collapse and merger of stars. The problem there is we see supermassive black holes at the very beginning of the universe, from a time when not enough stellar mass black holes could have merged together to form them. So this new study further supports the theory that giant black holes are born already weighing several thousand times the mass of the Sun. If the other idea were true, one would have expected smaller galaxies to likely have the same fraction of black holes as their larger counterparts, and they don't. This is SpaceTime. Still to come, still no evidence of alien signatures from the interstellar Comet 3I Atlas, and NASA begins new tests on how rocket plumes interact with the lunar surface. All that and more still to come on SpaceTime. Well, this is the silly season for news, and so those wacky claims that the interstellar comet 3i Atlas could be an alien spacecraft aren't going away. Since this space rock was first detected back on July the 1st last year, astronomers have been studying it in great detail. You see, it's only the third interstellar visitor identified in our solar system. The first was 1I Oumuamua, a long, thin, cigar-shaped asteroid detected back in 2017 just as it was leaving the solar system. It had a reddish hue like many Kuiper Belt objects, and it lacked the traditional cometary coma and tail. But it did display an unexpected non-gravitational acceleration as it left the solar system. That led to claims ranging from natural phenomena like cosmic rays bombarding the asteroid and releasing trapped hydrogen ice as gas to explain the push, right through to more, shall we say, speculative claims of alien technology, often by the same characters making these latest claims about 3i Atlas. The second confirmed interstellar visitor was the comet 2I Borisov, which passed through our solar system in 2019. It turned out to be surprisingly similar to our own solar system's comets, but with high levels of carbon monoxide, suggesting formation in a dense, pristine environment before being flung into interstellar space and eventually making its way into our neighbourhood. There have undoubtedly been many other interstellar visitors, but it's only now that we've gotten really good at identifying them. And of course, now there's 3i Atlas. Everyone, from publicity-seeking scientists to ambulance-chasing reporters looking for clickbait, have pounced on allegedly anomalous data claiming to show strange happenings emanating from 3i Atlas and suggesting that it must mean it's evidence of technologically advanced alien civilizations from beyond our solar system. Now, we've already covered all this previously on SpaceTime, showing how this comet is behaving exactly as what one would expect for an object on a hyperbolic orbit originating in another star system. Its unusual chemicals and the timing of their sublimation or releases are caused by the chemical composition of the star system it originated from, and so would be expected to be different from ours. And its trajectory is exactly as expected for a space rock encountering the gravitational pull of our Sun after travelling in that specific direction. Recent changes in its trajectory are not caused by alien rocket thrusters, but the release of gases from inside the comet due to heating from the Sun, which are then acting as thrust. So, why are we rehashing all this? Well, a new study has just been released, which has been reported on the pre-press physics website archive.org, which is saying basically the same sort of stuff we did. The new findings are based on observations by the 100-metre Green Bank radio telescope in West Virginia. They were made as part of the Breakthrough Listen program, which is specifically designed to look for signs of alien life. The data was collected on December the 18th. That's the day before the comet made its closest approach to the Earth. Scientists looked at 4 key radio bands covering the 1 to 12 gigahertz range right around the time of the comet's closest approach. Their search picked up some 471,000 candidate signals. They then filtered those down to just 9 candidate events, all of which were found to be caused by radio frequency interference, as they also appeared in off-target scans or known contaminants. As well as Greenbank, multiple other astronomical telescopes and observatories have taken data on Comet 3i Atlas at various wavelength bands, including radio, infrared, X-ray and optical, all of which have been carefully analysed by hundreds of scientists. And according to SETI, the Search for Extraterrestrial Intelligence, none of these observations, absolutely none, have resulted in any evidence of alien technological signatures. This is SpaceTime. Still to come, NASA's begun using a new camera system to test how rocket plumes affect the lunar regolith, and later in the science report, a new study has shown that dog ownership could result in a stronger sense of community. All that and more still to come on SpaceTime. NASA's begun using a new camera system to study how rocket plumes affect lunar regolith, the rocks and dust that blankets the lunar surface. The data will help scientists better understand the hazards that may occur when a lunar lander's engine plumes blast away at moondust, soil and rocks. The data will also be used by NASA's commercial partners as they develop their own landing systems to safely transport astronauts from lunar orbit to the moon's surface and back again, beginning with the Artemis 3 mission. To better understand the science of lunar landings, scientists from NASA's Langley Research Center in Virginia initiated a series of plume surface interaction tests inside a massive 60-foot spherical vacuum chamber. NASA's Ashley Curzon, who led the testing, says these plume surface interaction ground tests are the most complex of their kind to be undertaken in a vacuum chamber. The idea is to see how much of the debris kicked up by a rocket plume exhaust ends up hitting the landing vehicle or nearby lunar rovers or other equipment. Curzon says understanding these physics is pivotal to ensuring crew safety and mission success. The campaign, which will run right through the early part of 2026, should provide an absolute treasure trove of data that researchers will be able to use to improve predictive models and influence the design of future space hardware. Curzon's team are testing 2 types of propulsion systems in the vacuum sphere. The first round of tests will use an ethane plume simulation system designed by NASA's Stennis Space Center in Mississippi. The ethane system generates a maximum of 100 pounds of thrust. After completing the ethane tests, the second round of tests will involve a 14-inch 3D printed hybrid rocket motor, which was developed by the Utah State University and tested at NASA's Marshall Space Flight Center in Huntsville, Alabama. It produces around 35 pounds of thrust, igniting both solid propellant and a stream of gaseous oxygen to create a hot, powerful stream of rocket exhaust, simulating a real rocket engine but at smaller scale. The researchers will be testing both types of propulsion systems at various heights, firing them into a roughly 6.5-foot diameter, 1-foot deep bin of simulated lunar regolith called Black Point 1, which is jagged, cohesive particles similar to real lunar regolith. A number of different instruments, including a version of the camera system that imaged the plume surface interaction during the Blue Ghost lunar landing last year, will capture data and imagery from the tests, which will last about 6 seconds each. The instruments will measure crater formation, the speed and angle of ejector particles, and the shapes of the engine plumes. Curzon says this test campaign will be far more than just a one-shot moon-specific thing. The entire operation's modular by design, and so it can prepare NASA for missions to Mars as well. The lunar regolith simulant can be replaced with Mars simulant, which will be more sand-like, and pieces of hardware and instrumentation can all be unbolted and replaced to better represent future Mars landers. Curzon says rather than take the vacuum sphere down to really low pressure like on the Moon, it can be adjusted to a slightly higher pressure that simulates the atmosphere on the red planet Mars instead.
When we go back to the Moon with the HLS, or Human Landing Systems program, we're going with commercial partners this time, and we're taking vehicles that are much larger and much more powerful than the vehicles that we flew to the Moon for Apollo. We're going to simulate what happens when you take a rocket engine really close, as if you were landing on the surface of the Moon. So we're going to conduct testing under reduced atmosphere conditions to be as moon-like as possible. We're going to simulate lunar descent engines using a couple different approaches, and we're going to impinge those rocket exhaust plumes onto some simulated moon dirt. We want to understand how a crater forms underneath the vehicle, and as well as what we call ejecta. So where does all of the lunar regolith that we've moved with that rocket engine, where does it go? Does it hit our vehicle? Does it hit other assets that are near us, payloads? How does that impact science? How do we plan what we do on the surface? All of those types of things are what data from this test will help inform.
That's Ashley Curzon from NASA's Langley Research Center in Hampton, Virginia. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that microplastics could be fueling neurodegenerative diseases like Alzheimer's and Parkinson's. The findings, reported in the Journal of Molecular and Cellular Biochemistry, highlighted 5 ways microplastics can trigger inflammation and damage the human brain. These include triggering immune cell activity, generating oxidative stress, disrupting the blood-brain barrier, impairing mitochondria, and damaging neurons. Native Australian animals range from high-hopping kangaroos to fast-running emus, but clever little betons also have a special ability to find and eat the food they love. Scientists at Flinders University have discovered the secrets behind a superpower for these tiny relatives of kangaroos, which allows them to crack open seeds that would break the jaws of most animals. Bettongs have specially adapted jaws to crack open hard shells. Burrowing betons have short snouts for leverage, while bush-tailed betons have reinforced skulls and powerful premolars. Both types find seeds by smelling and digging, often burying them first, which can help pre-crack them as they dry out. Then they use their teeth, together with manipulation from their forepaws, to access the kernels inside. The findings, reported in the Zoological Journal of the Linnean Society, are designed to help conservation efforts, including finding suitable locations to reinforce populations severely impacted by habitat loss. A new study has shown that dog ownership could result in a stronger sense of community. The findings, reported in the journal PLOS ONE, involved social surveys of 377 people in Tokyo. The authors found that dog ownership was associated with an increase in anchored personal relationships, a type of relationship that revolves around a shared time, place and activity, such as walking around the block or visiting the dog park. The study found these were more likely to have a bigger impact on a sense of community than friendships, which the authors say may be because people seen walking their dogs are more likely to be residents of the same neighbourhood, while friendships are often formed for reasons other than living close by. Well, it looks like all those post-Christmas Boxing Day sales have now reached the supernatural community. Despite all their clairvoyance and fortune-telling abilities, it looks like they couldn't foresee the surplus of ghost hunting equipment and other supernatural paraphernalia they've got left in stock following the holidays. Skeptics Tim Mendham says if you ever wanted to start up your own ghost hunting business, now's the time because there are bargains to be had. And you certainly will be.
Dowsing rods, I'd hate for anyone to recommend that anyone shells out their hard-earned money on buying some dowsing rods, but there's one particular set that has cropped up, which is two rods. There's basically two wooden handles with a drilled out through the middle and then a bent metal rod that goes through the handle and out at an angle. And you've got a little bag to keep things in and all sorts of stuff like that. Interestingly, water witching, they describe it as, also can be used for finding ghosts, all sorts of things. And of course, mining, surveying, that sort of stuff. And they were selling for, I think it's American, about $17. So it's now been dropped to $7. Of course, you can make your own. Just get a couple of bits of pipe, a bit of PVC pipe, take some coat hanger, bend it and stick it through the short end through the pipe, and then off you go. Of course, the cheapest one is getting a forked stick. You go down to your local tree.
Speaking of the forked stick.
Yeah, the forked stick. Some people said it has to be a certain sort of tree, a yew tree or something like that. I don't know how many yew trees there are in your neighbourhood. But I mean, honestly, it's probably just as good as anything else. Yeah, so there's all sorts of gear. You got all the online shops. You get your electromagnetic frequency meters and things, which is normally used for electronic sort of things that you can use it to find energies. Yeah. There's also the radio scanners, which is the things you can set to sort of zip through all the channels on the radio frequencies, and you'll hear noises and things. Because you can set the level of zipping, so if you make it fast enough, you really can't get a clear picture of all the words that are used. But you'll definitely hear some words as it flips past the channels, and that makes it sound more intriguing. If you have it on slow, you get to hear more of the words that you realise it's just someone giving a recipe for pumpkin soup or something, right? But if it goes through quickly, it sounds very impressive. You can get those, and because all sorts of things, you can get apps for your phones to find the ghost. Most of these things, when you use them in a ghost hunting, these electronic things, the EMF meters, some of them are picking up your phone, and all sorts of electrical disturbances from all sorts of things that people carry. There might even be cross-pollinating between different ghost hunting equipment. You can outfit yourself quite easily. You don't have to hire in a professional. You can get all sorts of gear. It's just as effective as a bit of stick or with a plumb bob or something, and off you go.
That's the Skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.